we want to solve the equation 2x minus 6 equals 1. And because 2x means 2 times x, the solution to the equation is the value of x that makes 2 times x minus 6 equal to 1. In order to solve the equation for x, we need to isolate x on one side of the equation, and because the x term is on the left side of the equation, our solution will be in the form x equals some value, again, that makes the expression 2x minus 6 equal to positive 1. Looking more closely at the left side of the equation, in order to isolate x, we need to undo this multiplication and undo the subtraction. Because we have two operations to undo, this is often called a two-step equation. To solve a two-step equation, step 1 is always to undo the addition or subtraction to isolate the variable term, and step 2 is to undo the multiplication or division to isolate the variable or solve for the variable. So looking back at our equation, the first step is to undo minus 6 by performing the inverse or opposite operation. And therefore, to undo minus 6, we will add 6 to both sides of the equation. Plus 6 will undo the minus 6. So we'll add 6 to the left side of the equation, and whatever operation we perform to the left side of the equation, we must also perform to the right side to maintain equality. So we also have plus 6 on the right. And now simplifying both sides of the equation, the plus 6 undoes the minus 6, or negative 6 plus 6 equals 0. So these two terms simplify out, and now we just have the variable term 2x on the left side. So we have 2x equals, on the right side we have 1 plus 6, which equals 7. Now again, because 2x means 2 times x, the second step is to undo this multiplication. To undo multiplying by 2, we perform the inverse or opposite operation, and therefore to undo multiplying by 2, our second step will be to divide both sides of the equation by 2. Dividing by 2 will undo multiplying by 2, and therefore we also divide the right side by 2. Now looking at the left side of the equation, dividing by 2 undoes multiplying by 2, so the left side simplifies to just x. This is also 2 divided by 2, which equals 1, and 1 times x is just x. On the right side, we have 7 divided by 2, or the fraction 7 halves, and the fraction 7 halves does not simplify because the only common factor between 7 and 2 is 1, and therefore our solution as a fraction is 7 halves. We could also convert 7 halves to a decimal by dividing 7 by 2. Let's go ahead and show that. 7 divided by 2, there are 3 2's in 7. 3 times 2 is 6. Subtracting 7 minus 6 is 1. If we want to convert to a decimal, we'd add a decimal point to the right of 7, move it up to the quotient, and then add a 0 in the tenths place value. Then we can bring the 0 down. Notice how there are exactly 5 2's in 10. 5 times 2 is 10. Subtract. Because the difference is 0, we now know our quotient can also be expressed as 3.5. So because 7 halves is equal to the terminating decimal 3.5, we could also express this as 3.5. But what we should never do is convert a fraction into a decimal and then round, because by rounding, we would not be given the exact solution. Before we go, let's check our solution by substituting 7 halves for x into the original equation to make sure it satisfies the equation. So performing the substitution, we would have 2 times 7 halves minus 6 equals 1. And notice how this simplifies very nicely. This is the same as 2 over 1, and 2 over 2 simplifies to 1 over 1. So this product is just 7. 7 minus 6 equals 1. 7 minus 6 is 1, so we have 1 equals 1, which is true, verifying our solution is correct. I hope you found this helpful.